Good morning and welcome dear students. Today we will be starting a new lesson from Science and Technology Part 1, Lesson number 5, Heat. So let's begin. First, introduction. Now children, can you recall what is the difference between heat and temperature? Let's see. Heat is a form of energy. Temperature. Through the temperature, the quantum of the heat of the substance is expressed. Heat. Particles of matter, atoms, molecules, etc. possess potential energy and kinetic energy. Total energy, that is potential energy plus kinetic energy of all the particles of matter in a given sample is called its thermal energy. And temperature, it is a quantitative measure of degree of hotness or coldness of a body. Understood? Let's see the next point. When two bodies at different temperatures are in thermal contact with each other, there is a transfer of thermal energy from a hot body at higher temperature to a body at a lower temperature. Okay, and temperature, it determines the direction of energy transfer. Heat is explained in joule, calorie and erg, and temperature is expressed in Celsius, Faraday and Kelvin. Now let's see the next. So children, what are the different ways of heating? It is conduction, convection and radiation are the waves of heat transfer. In our previous standards, we have learnt about heat and different types of heat transfer. We have also performed few experiments related to expansion and contraction of solids, liquids and gases, isn't it? We have learnt about the difference between heat and temperature also. We have seen how temperature is measured using a thermometer. Now children, latent heat or phase transformation, anomalous behavior of water, dew point humidity, specific heat capacity. So we are going to learn which all these which are related to certain phenomena experienced by us in our day-to-day life. Let us learn more about these concepts. The first one, latent heat. So let's try this. Take a few pieces of ice in a glass beaker as shown here. Insert the bulb of a thermometer in the ice and measure its temperature. Put the beaker on the stand and heat the ice using a burner. Record the temperature using the thermometer after every minute. As the ice is heated, it starts melting. Stir the mixture of ice and water. Continue the heating even after ice starts melting. Draw a graph of temperature versus time. You will observe that the temperature of the mixture remains 0 degrees Celsius till the ice melts completely. If we continue heating, even after conversion of all the ice into water, the temperature of water starts rising and reaches 100 degrees Celsius. At this temperature, water starts converting into steam. The temperature of water remains constant at 100 degrees Celsius till all the water converts into steam. The graph of temperature versus time is shown above. In this graph, line AB represents conversion of ice into water at a constant temperature. When ice is heated, it melts at 0 degrees Celsius and converts into water at this constant temperature. The ice absorbs heat energy during transition, and the absorption of energy continues till all ice converts into water. The temperature remains constant during this transition, and this constant temperature at which the ice converts into water is called melting point of ice. Thus, during transition of solid phase to liquid, the object absorbs heat energy, but its temperature does not increase. This heat energy is utilized for weakening the bonds between the atoms and molecules in the solid and transforms it into liquid phase. The heat energy absorbed at constant temperature during the transformation of solid into liquid is called the latent heat of fusion. So, the amount of heat energy absorbed at constant temperature by unit mass of a solid to convert into liquid is called the specific latent heat of fusion. Once all the ice is transformed into water, the temperature of water starts rising. It increases up to 100 degrees Celsius. Line BC in the graph represents rise in temperature of water from 0 degrees Celsius to 100 degrees Celsius. Thereafter, even though heat energy is supplied to water, its temperature does not rise. The heat energy is absorbed by water at this temperature and used to break the bonds between the molecules of the liquid and convert the liquid into gaseous state. Thus, during transformation from liquid phase to gas phase, heat energy is absorbed by the liquid, but its temperature does not change. The constant temperature at which the liquid transforms into gaseous state is called the boiling point of the liquid. The heat energy absorbed at constant temperature during the transformation of liquid into gas is called latent heat of vaporization. The amount of heat absorbed at constant temperature by unit mass of a liquid to convert into gaseous phase is called the specific latent heat of vaporization. Different substances have different melting points and boiling points, and the value of melting points and boiling point and latent heat depends on atmospheric pressure. Now children, use your brain. Is the concept of latent heat applicable during the transformation of gaseous phase to liquid phase and from liquid phase to solid phase? Yes, the concept of latent heat is applicable during transformation of gaseous phase to liquid phase and from liquid phase to solid phase. Where does the latent heat go during these transformation? So during these transformation, the latent heat is given. Understood, children? Now let's see the next. The next we have is regulation. You may have seen the preparation of an ice ball. First, an ice slab is shredded and then the shredded ice is pressed around the tip of a stick to prepare the ice ball. How does the shredded ice convert into solid ice ball? If two small pieces of ice are taken and pressed against each other for a while. They stick to each other. Why does this happen? Because of the regulation process, this process happens. Like shredded ice conversion into the solid ice ball. Small pieces of ice stick to each other when they are pressed against each other for a while. The phenomena in which the ice converts to liquid due to applied pressure and then reconverts to ice once again, the pressure is removed, is called regulation. Now children, let's try this. Take a small slab of ice, a thin wire, two identical weights. So, put a slab of ice on a stand as shown above. Hang two equal weights to the two ends of the metal wire and put the wire on the slab as shown in this figure. What do you observe here, children? It is observed that the wire gradually penetrates the ice slab. After some time, the wire comes out of the lower surface. However, the ice slab does not break. The phenomena in which the ice converts to liquid due to applied pressure and then reconverts to ice once the pressure is removed is called regulation. Understood? The melting point of ice becomes lower than 0 degree due to pressure. This means that at 0 degrees Celsius, the ice gets converted into water. As soon as the pressure is removed, the melting point is restored to 0 degrees Celsius and water gets converted into ice again. Use your brain power now. In the above experiment, the wire moves through the ice slab. However, the ice slab does not break. Why? In the above experiment, the wire moves through the ice slab. However, the ice slab does not break because when the thin wire with two equal weights attached to its end is hung over the block of ice, it exerts pressure on the ice below it. Due to this, the melting point of ice below the wire is lowered and some ice melts. The wire passes through the water so formed. The water above the wire is no longer under pressure and therefore refreezes. Once again, the ice below the wire melts and the wire passes through it and the process continues. In this way, due to alternate melting of ice and refreezing of water, the wire cuts right through the block of ice, leaving the block intact. Got it? Is there any relationship of latent heat with this regulation? Relationship of latent heat with the regulation is as follows. When ice melts, heat is absorbed, but the temperature does not change. Also, when water freezes, heat is given out, but the temperature does not change. This heat absorbed or given out is the latent heat. You know that as we go higher than the sea level, the boiling point of water decreases. What would be effect on the melting point of solids? As we go higher, that the sea level, the pressure on the substance decrease. Due to decrease in pressure, the boiling point of water decreases, but melting point of ice increases. Understood, children? So, can you tell me? We feel that some objects are cold and some are hot. Is this feeling related in some way to our body temperature? We feel that some objects are cold and some are hot. This feeling is related to our body temperature in the following way. If the temperature of the object is lower than our body temperature, example ice, we feel the object is cold. If the temperature of the object is higher than our body temperature, for example hot water, we feel the object is hot. Okay, now the next one is anomalous behavior of water. In general, when a liquid is heated up to a certain temperature, it expands, and when it cools, it contracts. Water, however, shows a special and exceptional behavior. If we heat water from 0 degrees Celsius up to 4 degrees Celsius, it contracts instead of expanding. At 4 degrees Celsius, its volume is minimum due to contraction. If the water is heated further, it expands and its volume increases. The behavior of water between its temperature from 0 degrees Celsius to 4 degrees Celsius is called anomalous behavior of water. If 1 kg of water is heated from 0 degrees Celsius and its volume is plotted as a function of temperature, we get the graph shown as above. At 4 degrees Celsius, the volume of water is minimum. It means that the density of water is maximum at 4 degrees Celsius. Now, study of anomalous behavior of water using Hope's apparatus. The anomalous behavior of water can be studied with Hope's apparatus. In Hope's apparatus, a flat bowl is attached to a cylindrical container as shown above. There is a provision to attach thermometers above to measure temperature T2 and below to measure temperature T1. The flat bowl on the cylindrical container, water is filled in the cylindrical container and a mixture of ice and salt is put in the flat bowl. During the study of anomalous behavior of water using Hope's apparatus, temperature T1 and T2 are recorded after every 30 seconds. The temperature are plotted on the y-axis and the time in minutes on the x-axis. The graph is shown above. The graph shows that initially both the temperature T1 and T2 are identical. However, as time passes, the temperature T1 of water in the lower part of the cylinder decreases fast, while the temperature T2 of water in the upper part of the cylinder decreases comparatively slowly. However, once the temperature T1 of the lower part reaches 4 degrees Celsius, it remains almost stable at that temperature. T2 decreases slowly to 4 degrees Celsius. Thereafter, since T2 starts changing rapidly, it records 0 degrees Celsius first. And after that, the lower thermometer T1 records 0 degrees Celsius temperature. The point of intersection of the two curves shows the temperature of maximum density. How can we explain these observations? Initially, the temperature of water in the middle of the cylinder lowers. Due to freezing mixture in the outer bowl, since the temperature of water there decreases, its volume decreases and its density increases. The water with the higher density moves downwards. Therefore, the lower thermometer T1 shows rapid fall in temperature. And this continues till the temperature of water becomes equal to 4 degrees Celsius. When the temperature of water starts decreasing below 4 degrees Celsius, its volume increases and density decreases. Therefore, it moves in the upward direction. The temperature of water in upper part, that is T2, therefore decreases rapidly to 0 degree. The temperature of water in the lower part, however, remains at 4 degrees Celsius for some time and then decreases slowly to 0 degrees Celsius. Children, now use your brain and tell me, how will you explain the following statements with the help of the anomalous behavior of water? In the regions with cold climate, the aquatic plants and animals can survive even when the atmospheric temperature goes below 0 degrees. In regions with cold climate, the aquatic plants and animals can survive even when the atmospheric temperature goes below 0 degrees Celsius. We can explain this statement in the following way. Due to anomalous behavior of water, its density is higher at 4 degrees Celsius. In cold regions, when the temperature of the atmosphere falls down, the water at the surface of lakes and ponds starts contracting. Hence, its density increases and it sinks to the bottom. And the water of the less temperature uplifts to the surface, then it is converted into ice. But the water below the layer of ice is at 4 degrees Celsius. Ice is bad conductor of heat. Hence, the layer of the ice at the surface does not allow transfer of heat from the water to the atmosphere. As the water below the layer of the ice remains at 4 degrees Celsius, fish and other aquatic animals and plants can survive in it. Got it? In cold regions in winter, the pipes for water supply breaks and even the rocks crack. Isn't it? In the cold regions in winter, the pipes for the supply breaks and even the rock cracks. We can explain these statements in the following way. In cold regions, the temperature of the atmosphere falls below 0 degrees Celsius in winter. So, when the temperature of the water falls below 4 degrees Celsius, it expands and ice is formed. There is an increase in the volume. At this time, as there is no room for expansion, water or ice exerts a large pressure on the pipes. Hence, the pipelines carrying water burst. Same happens with the water which enters into the crevices of the rocks, and the rocks break up into small pieces. Got it, children? Now let's see the summary what we have learned today. The amount of heat absorbed at constant temperature by unit mass of a solid to convert into liquid phase is called the specific latent heat of fusion. Are you getting me, children? The next what we have learnt is the amount of heat energy absorbed at constant temperature by unit mass of a liquid to convert into gaseous phase is called the specific latent heat of vaporization. The next what we have learnt is regulation. When water is frozen and pressure is supplied to a certain area, that area will melt, then immediately refreeze upon removal of the pressure. This is called regulation. An example of regulation is making a snowball. We have seen this. Now the abnormal or anomalous behavior of water. At 4 degrees Celsius, water has its highest density. It actually contracts as the temperature rises from 0 degree to 4 degrees Celsius. This means that in regions with severe winters, lakes cool at the surface, and when the surface water reaches 4 degree, that water being more dense sinks. A temperature gradient is set up, and when the water freezes, it does so at the surface. Eventually, the ice which floats on water acts as an insulator, protecting the water below it from further cooling. This results in lakes freezing from the top down and not from the bottom up. This means that fishes can survive below the ice even if the air temperature is far below 0 degrees Celsius for prolonged periods. Understood, children? So, with this, we have finished with today's topic. I hope everyone has understood today's topic, children. Please read the lesson also after watching this video. So, in the next video, we shall learn a new topic from this lesson. Till then, take care, children. Thank you very much.